Okay, so uh, this is this this lecture notes is from this MIT OpenCourseware, and we'll use that for our course as well. And before this is recorded in 2005 by Professor Eric Deman, okay, and also this Lyserson, that is the CLRS book writer, this Lyserson, both combinedly took this course. Okay, this lecture slide is from their course. Okay, so this is a very interesting lecture slides they have made. Okay, you can go through all the lecture slides from their course. Okay, and for their video as well. Okay. This is recorded in 2005. After that, Professor Deman has taken several courses, right, and regarding these algorithms, design and analysis of algorithm, and till date he is taking the course. But this course, this 2005 course, I think is one of the best. Okay, and this Professor Deman, he is working in this computational origami, computational origami, and I think you have heard about this term origami. Okay, you have made several different paper boats and all these things. Okay, aeroplanes, right? Thank you. Okay, so this is this course is from MIT OpenCourseware. These lecture slides, and it is taken by this Professor Eric Deman and by Lyserson. And this Professor Deman is working on this computational origami. Okay, so this you have done several origamic. Okay, okay, so this origami he is working on, and this you have made several different paper boats, paper aeroplane and all others, flowers. So what he has done is he has given a mathematical framework for this. Okay, or in from computer science parlance, we should be telling that he has given a computational, that means algorithmic structure he has brought into this. Okay, so this is very interesting subject, and this is one of the subfields of computational geometry. Okay, some of the computational geometric algorithm will be having in our be doing that as well. So computational geometry. Huh? Sorry, what? How it is getting muted, I don't know. Let me do one thing. Stop presenting and then Okay, is it is it audible now? Okay. Okay, so you should be going through this course whenever possible for a better understanding of the algorithms that I recommend. Anyway, so this is this lecture slides will be taking in our course as well. Okay, so before going to this divide and conquer this algorithm, one one topic that was not discussed earlier, one asymptotic notation that was, I told that this will be omega notation, okay, small omega. So little omega, this is small omega or little omega, right? And we have got this big omega of n. Say this fn equal to 2n plus 3, and we have got that this is greater equals to say 2n for some constant c and n naught, right, for some constant. So this has been true, right? And then we have said that fn equal to this omega n as well. Okay, so the condition fn should be okay, you wait and maybe it's a restarting problem. Okay, so just I'm restarting. Hello. 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 That I can do, but no, I'm not doing that. I'm not at all doing that. Then again, I have to check whether internet is. Just you wait. Okay, I'm restarting. Yes, it will be solved. Okay. Just you wait. Okay, you don't go away.